Hello, good morning, good afternoon, or good evening, whatever time zone you're joining us from. This is Jim McKeith, and welcome to this webinar today on events-based and asynchronous programming. Dalia is online to talk with you about her book, and we're also going to do some Q&A. Also online with us today is Stephen Ball, which you may recognize from the community as well, and he'll be helping with Q&A. I do have to juggle a dentist appointment immediately after this. So depending on how far long it goes, I may have to cut out early. So anyway, Stephen's online to help with that. And with that, we'll go ahead and kick it off. Thanks a lot. Thanks for joining us.
Hi there. Today we are going to talk about the new book we published, about event-based and asynchronous programming in Delphi. My name is Dalija Prasnikar and I am a software developer and photographer, crashing other people's software and writing my own since '85.
And I'm Nevan Prasnikar, unable to remember when I started doing the same. Now, although I wrote some parts of the book and hunted down all or most of the errors my mom made, she's the frontman here. She's much more popular in the Delphi community and an Embarcadero MVP to boot, so she'll be answering your questions in the Q&A session hosted by Jim McKeith later on. Enjoy her Eastern European accent. Meanwhile, me and my lighter accent will be handling the book overview. Event-based programming is everywhere. Nowadays you can hardly write any kind of application without leaning on events and messages. This simple yet extremely powerful mechanism is also the cornerstone of asynchronous and multi-threaded programming. Without events, we would not know when a given task was completed. But asynchronous and multi-threaded programming consists of more than just handling multiple threads, protecting shared resources, and synchronization. It also includes designing and understanding the flow of the program. That design aspect is often forgotten, taken for granted, and solving all the fine-grained nuances of multi-threaded programming hogs the spotlight. Without understanding asynchronous flow and the bigger picture, it can be hard to properly solve all the other issues, including multi-threading. What used to be plain spaghetti code now becomes temporal spaghetti. You can lose control over your objects, have bits of code creating and releasing them all over the place, even without adding multi-threading into the mix. Memory leaks, crashes, and holding references to dead data long after its destruction are perfectly possible even in a single-threaded environment. Now, the book starts by giving a proper introduction to event-based and asynchronous programming flow and design, but it also provides the assorted implementation details, explanations, and code examples needed to put those designs into practice. So, here we are in part 1, the loop. The main event loop, also known as the application event loop, is the central building block of all GUI applications. The main loop is responsible for receiving messages sent by the OS, other processes, or the application itself, and dispatching them to appropriate event handlers in the application. When you create a new Delphi application, either VCL or FireMonkey based, drop a button on the form, double-click on the button, and attach an on-click event handler to it, you are basically doing event-based programming. Event-based programming is the backbone of modern software, from operating systems to desktop applications, mobile applications, games. Anyone who knows me understands why I'd want to mention that last one. It has extremely simple and easily understandable logic behind it, and yet it is powerful and versatile, and allows you to build the most complex of systems around it. Moving on, we have part 2, messaging systems. Delphi originated on Windows, and its original event handling architecture is built on top of the Windows messaging system. This part of the book covers the Windows messaging system, as well as its integration with Delphi. In cross-platform applications, you can't use the Windows messaging system, and if you need it in FireMonkey applications, you can use the cross-platform messaging system in the system messaging unit instead. This one can also be used in VCL applications because it isn't bound to any visual framework. Beyond what Delphi provides out of the box, there are no limitations preventing you from using any custom-made messaging system or pattern you want, such as the observer pattern or the publish-subscribe pattern. Next up is Part 3, Life, the Universe, and Everything. Asynchronous and multi-threaded programming is rather complex, and you will often need all the help you can get out of various language features. The most helpful are automatic memory management and anonymous methods. However, they also have some limitations, so it is important to be familiar with all of their ups and downs before you set sail into multi-threading waters. Anonymous methods and their ability to capture variables from outside contexts are an extremely important and almost indispensable feature, even in fairly simple scenarios and frameworks. While you can certainly handle any of those without using anonymous methods, their usage greatly simplifies your code and makes it more readable. Continuing on from the topics of Part 3, we have Part 4, Asynchronous Programming and Multithreading. Just to really dig in there. Application process messages was the poor man's tool to keep the user interface responsive while the application is performing a long-running task. This part of the book gives you step-by-step instructions on how to remove application process messages and switch to using background threads instead. Creating and destroying threads is quite a slow process. If you have tasks that create and destroy a lot of fairly short-lived threads, reusing those threads and just feeding them with new tasks would be a faster approach than recreating them. This is the basic idea behind any task-oriented framework. The Delphi parallel programming library in the system threading unit implements one such task-oriented framework. Running multiple tasks, where one task depends on another task, can result in convoluted, scattered code, where it is hard to follow the flow of the code. In order to alleviate such problems, the future pattern allows us to streamline our code flow in such scenarios. After we've wrapped up asynchronous programming, it's time for Part 5, Thread Safety. The main issue when writing multi-threaded code is thread safety, but in order to write thread-safe code, we need to know what thread-safe code actually is. Thread safety is highly context-dependent. Literally the same code can be thread-safe in one scenario and unsafe in another. Because of that, it can be easy to wrongly assume that some code is thread-safe when it's not thread-safe at all. While there are no ready-to-go recipes for writing thread-safe code in all scenarios, some code is inherently unsafe. Learning to recognize thread-unsafe code is the first step towards achieving thread safety. Once you can tell the difference between thread-safe and unsafe code, you can apply the proper coding patterns and protect shared data in multi-threaded scenarios, making the code handling that data thread-safe. As a general rule of thumb, when you're wondering if it's thread-safe, assume it's not. Finally, we have Part 6, GUI and Multithreading. Long-running tasks in background threads often need to communicate with the main thread, if for no other purpose than to show their progress to the user. There are several ways to implement such communication, but the most common approaches are to use messaging systems, either the OS-provided ones or stuff from custom frameworks, or to use thread synchronization to execute blocks of GUI-related code within the context of the main thread. No matter which communication approach is used, you will face two main problems: avoiding deadlocks, and the more prominent one, using references to controls and data that have already been destroyed. This part of the book covers several ways of safely avoiding such issues. Well, that's all, folks. From me, anyways. Thank you for watching. You can find the books at the website shown here. And now, to the interview and the Q&A session with Jim McKeith.
Thank you, Dalija, for this being part of this webinar today and for your book you just written. And I understand the print book is coming out very shortly. And then everybody who buys the ebook gets a discount on the print book, which is what I love.
Yes.
I love print books, but ebooks are great for referencing quickly too. So fantastic. So we have a few questions here, but as more questions come in during the live webinar, just put them in the question panel on GoToWebinar, and we'll get to those as well. So I guess the first question is why, or what is event-based programming, and why does the average Delphi developer care? Why should they care?
Well, they don't have to care, but they are using it every day.
Okay.
Well, when you drop a button on a form, you are basically a touch event handler, and you are basically doing event-based programming in Delphi.
So that's the whole idea where the event handling events. That makes sense.
You have some event, something happens, operating system or application or some other application sends you a message, and you handle and dispatch that to an appropriate event handler. And that's the basic of event-based programming.
Okay. So I remember when I came to Delphi from console applications that I had that paradigm shift of dealing with that things didn't seem to happen in the order I expected them to always. They could happen in different orders based on user input. So when I'm doing event-based programming, does that mean I'm working in multiple threads at this point? Is it a multi-threaded application?
No, you are basically doing, you're using single thread.
Okay.
Unless, okay, you can have frameworks that are behind that you're using threading behind your back that you don't know. But basically, no, you are using single thread unless you start some separate thread and put the task in the background.
So I remember early on in my learning to work with the event-based model Delphi uses that it was really common to use application process message and sleeps and stuff like that. When should I use application process message and sleep, and is that the best way to deal with?
No, well, basically that was used for a long time, but abused because it was easy.
Yes.
You don't have to deal with multi-threading, and it was much easier to use application process messages to handle some long-running task and keep the UI responsive. Windows are much more tolerant for such processes, and Android will, for instance, kill your application in a few seconds if you don't pump the message queue.
Yeah.
So basically, you cannot work like that in the other platforms. You need to change approach. And when you know what you are doing, when you're, for instance, when you are having some model dialog on Windows, then Delphi is pumping message queue in behind doing calling application process messages. But this is something the user shouldn't do unless they really know what they are doing.
So basically, all the times I used application process message because it's like, this isn't working. I'll just try application process message. I probably was using it wrong.
Well, maybe not. You cannot use it wrong. Using it is wrong.
Ah, okay. Got it.
That's the trick.
So is the secret then everything I write should be multi-threaded now? Is that what you're saying?
Well, it depends what you're doing. If you don't have some long-running tasks, then you don't have to do that. But anything that takes more than half a second, you need to put it in the background thread. For instance, some people think that accessing web servers or some web page or accessing disk files or networks, something like that, it runs fast. If it runs fast, they think they don't need to do anything and it will be okay. But then when users have bad connection and or you have a damaged disk drive or something like that, that operation can stall application for a very long time, and you will have Windows will try to ghost your application, and it will, you know what ghosting is.
Yeah.
It will show not responding message on your title bar and say, this is not working, it's dead. You need to process messages to let the Windows know that application is alive.
Okay. So, yeah, that's a really good point that that accessing REST services or web services or files, it can be fast. It's one of those things that it seems like a lot of times the developers, we have, hopefully powerful machines and good network connections and everything works great for us. But then once you get out in the real world, somebody's antivirus
Yes.
could be running in the background, or they could have firewall or connectivity issues. And so things really become unpredictable as far as performance goes. So if I put these long running tasks in another thread that makes my application run faster, is that what happens?
Well, not really.
Okay.
Multithreading doesn't make your application run faster. It makes it run slower. But for the user interface, that is the first requirement. You need to keep pumping Windows messages or any other OS you are running on to let know the OS that your application is alive. That is the first reason you would put something in the background thread, not just the speed, but keeping the user interface responsive. The next reason is speeding things up if you can use parallel execution on multiple cores, if you can parallelize your task. But not all algorithms are suitable for that kind of processing. But if you have multiple operations that you can spread across cores, then the whole thing will run faster in less time at the end, but it will processing time on each core will be longer than the running in single thread.
Okay, so if I understand correctly, single thread is the fastest as far as like execution time goes. But when you add multi-threaded or background threads, it's not about the first phase is not necessarily about speeding it up, but more about making your application more responsive so that it can handle the messages and the UI can remain responsive while these long-running tasks happen in the background. But then if we're able to divide it up into a lot of threads, then we could actually potentially, depending on the algorithm, improve the time the user's waiting for it, even though we've introduced more overhead with the threading. So what in the new parallel library, we have the idea of a T task. Is a task like the T thread that we've used for years, or what's the difference?
Yes, it's basically task is running a thread. Task is a separate item, and they are running on thread pool. The thing is, when you're having a lot of short tasks that you need to start, creating thread is a long process. It takes time to create and destroy thread. Okay. So it is much faster to use existing thread that is just sleeping. Okay. So this is the basic. You don't create a thread for each task, but you are using thread pool that serves you with ready-to-go threads.
So if I'm a developer that is currently using application process messages to make my application not hang, but I'm still trying to figure out how to keep my UI responsive, should I start by making my own threads, or should I start with T-task and using the thread?
Oh, that depends. If you
it always depends.
You can start with threads. For the simplest thing is using T-thread create anonymous thread procedure, and you just type code in the anonymous method, and you're done with it. Basically, this is the fastest, simplest scenario. But if you need to handle more tasks, it is better to use T-task than threads. But it depends. For instance, if you have some long-running operations that is constantly running in the background, you might want to have a dedicated thread for that. You don't want to use thread pool. But if you have short tasks, a lot of short tasks, then you would want to use T-task or some other thread pool-based framework.
Okay. Yeah, there's OmniThread and a few other frameworks out there for that, isn't there? So I noticed besides the T-task and the T-thread, there's also a T-future. Where does that come into play? Do I need a flux capacitor or time traveler?
No. Well, the future is actually a placeholder for the value, single value. That will be calculated sometime in the future. That is why it's called future. And usually this is also related with the term promise. You are making a promise that you will fulfill that value at some time. So if you have a task that needs to return some value, you can use T-future instead of the task. And if you have multiple tasks that depend one on the other, then you can serialize those tasks using futures, and your code will not be scattered all over the place because you have to use some messaging or event handlers or something to let them know next task that it can do some work based on the previous task and stuff like that. When you access the value, if it's not calculated, the thread will wait for the task to finish.
Okay, all right, so yeah. So you could, with a T feature, you could potentially block the main UI thread when you're reading.
Yes, if you call it on the main thread, you will block it. So you should not call it on the main thread, but you should run some task or some other thread and call the T future from that thread. The same goes for waiting for threads or tasks to finish in the main thread. If you wait, you will block the user interface. So you should only wait in extreme situations when you know that the task will finish in milliseconds, literally.
Is there a way to check to see if a future is already calculated or not?
Yes, I think there is a future result that will show you when the future is calculated. I'm not sure.
Okay.
I have to read the documentation.
It sounds like really your book is about like that paradigm shift from if we are still thinking in the non-event based like Pure Pascal or console applications.
First thing is many developers don't know that they are doing event-based programming.
Sure.
For instance, we had a message dialog on Windows that was blocking the dialog. Right. And with Android and iOS, you have async message dialog that has completion handler, and many people are not accustomed to such thinking. For instance, they write call the message dialog, and they expect that the line of code they write after that will run after the message dialog is executed, but that doesn't work like that. It only works if you have a blocking message dialog. When the user clicks on something, makes some action, then the completion handler will run, and the code logic you need to perform has to go in that completion handler.
Yeah. So as you're describing this, I was thinking about this more, realizing that when in Delphi, when we're, as you said, that when you have the events like a button click event handler, we're in event-based asynchronous programming, but we're not necessarily multi-threaded. And then when we're like writing some code and we're like, open this database, we know that next line is going to execute after the database finishes opening or after that REST service gets hit. But without some forethought, we're going to be blocking that main UI thread. And if that takes too long, we could end up hanging our application. So what this is really is taking the basics that we had to understand, that we may not understand yet about, that we are already asynchronously programming, and giving us the ability to then leverage that further to make our applications more responsive and to potentially write code. And then even though this line is calling a database or calling a REST service, this next line may happen before that finishes happening because it's happening asynchronously at that point. But then we have an event handler somewhere else that then handles when that finishes running. Is that correct?
Well, you can do that in different ways. If you pick the button handler that should not contain some business code, but we all do that.
Yeah.
If you take a button handler and you call some REST service or something in that handler, and it executes line by line until all the button handler finishes. If you move all that code in the background thread, that will also in that background thread execute synchronously, one line after the other. The only problem you have if you start tasks in parallel or you split that code for some reason more, or you use some other library or something that handles some things asynchronously, so you need to react on their completion handlers or some messaging or some events to perform some task. For instance, if you call Firebase on Android, it uses completion handlers to, you don't have an option to run it synchronously.
Right.
Complete library runs things in background threads. So you need to do stuff in completion handlers, and you cannot access the Firebase and retrieve some data from the web and run something in the next line and expect it to be after the Firebase has done its job.
So it sounds like potentially one solution might be that I could have a background thread, right? So I have my main UI thread that I get by default in Delphi, but then I could create a background thread and I could do all of my work in the background thread and then push updates to the UI. So someone clicks a button and it would say, hey, background thread, go do this. And then when the background thread's done, it could push an update back to the UI. Would that be a useful pattern?
Basically, that's how it's done.
Okay.
When you need to send, when you need to communicate with the main thread, you can always send some message, or you can synchronize the execution directly from the background thread to update some label or progress bar or something like that.
Okay, so that's the kind of the idea in the book, is this idea of how to synchronize between two threads or send messages between two threads.
Yes, basically that's how you communicate with between threads and between main thread and background threads.
What's the difference between sending a message and using synchronize?
Well, sending a message doesn't block the background thread, so it's much faster. And the main thread can then process those messages on its own time when it's ready to process, and background thread can continue to run as it were before. If it has to wait for the main thread, then it will run slower. So background thread will be running much slower than it should be. Okay.
All right. Yeah, so that's useful, because I think a lot of people just default to using synchronize, but it sounds like maybe sending messages might be a better solution.
Yes, generally yes, or using pthread queue instead of synchronize. And in the meantime, background thread can continue doing its job.
Fantastic, great. So frequently when I'm doing a webinar like on FireDAC or some other library, someone will ask a question if the library is thread safe. And especially like if I have a tech partner involved, I always have to defer to them. What is the best way that, as the average developer, without having to ask if something is thread safe, is there a way they can determine if something's thread safe or not, or what does that mean to be thread safe?
There are ways, but the best thing is reading documentation.
Okay.
Because otherwise you would need to look at the source code of that library and determine whether it is thread safe or not. And sometimes if it's a lot of code, it can be hard to figure it out. Generally, you have to assume that nothing is thread safe.
Okay.
Even the simplest thing, for instance, assigning one interface to another, assigning one string to another string, which is reference counted in Delphi, is not thread safe. So you cannot rely basically on anything.
So what does it mean to be thread safe versus not thread safe then?
Well, basically the definition says that thread safe code is the code that handles shared data in a way that multiple threads can safely access it in any order, in any time. That code should work as expected. So there will be no mixing of the threads. If two threads access the data at the same time, write, read, or whatever they are doing, that it will work as expected. So that definition is pretty vague. You cannot say this is thread safe and this is not. It really depends on context. You can always say some things are not thread safe, but some things depends on what the code needs to do.
Sure.
So there are some examples. For instance, you if you have some integer list that has uses locking for adding integers and retrieving them, that list is thread safe for that. But if you want to add unique integer into that list, you need to check whether integer already exists in the list, and then you have to add it if it is not in there. If you don't lock the whole code and just use the thread safe methods of add and get, you will write a thread non-safe code because you will be able to add not unique integer in the list. You can have double entries. So it depends on the context. Some things are not thread safe by default, but some things depend on what the actual correct behavior is.
So I understand thread safety basically means that it accesses the data in an atomic way, where that you always know it's in a good state. But
basically, yes, complete data has to be in good state. You cannot go in and write or read something in half or make a mess out of it. Atomic is usually used for atomic operations that are on their own. They don't guarantee thread safety. For instance, if you atomically increment integer or something like that, it only means that that integer will be, or some other data will be written consistently or read consistently. But it doesn't mean that the code you will write around it will be thread safe.
That makes sense.
You can only guarantee the consistency of the data.
So
atomic is not the best terminology in general when using thread safety.
So thread safety is not just a checkbox. I can just say, oh, it's all thread safe. I don't have to think about threading at all now. I can do whatever I want to.
No.
It's something you really have to understand the way it all works. Thread safety just means that if you do it right, it will work in a multi-threaded application, but you still have to know what you're doing and do it right. So I remember when you started to see dual core CPUs, and it became, if you weren't developing with a dual core CPU, your application could be totally different, especially if you had threads in your application when you went from a single core to a dual core. And so, yeah, threading it's really powerful, but it's really something you need to understand. So, it's good to have, this book. It sounds like that it covers kind of this whole idea. What is the synchronous? How do we do asynchronous programming? How do we do messaging? And how does that play into threading as such? I know that a lot of times when I hear people discussing functional programming, they talk about the importance that what's the term they use when you're immutable, right? So that all the data is immutable. So everything's a function that you never have. So you never are changing data. You're always creating new data, right? So
new copy, yes.
New copy.
Data is shared data is if it's in read-only mode. So if you're only reading it from multiple threads and none of the threads writes it, then it's thread safe. So there are some pieces we know that are thread safe. So if you can guarantee that no thread will write to some data before it starts running, you can fill the data before you spawn multiple threads, then that data will be thread safe. Only when writing comes in play, it is not thread safe. So immutable data, which is used in functional programming, when you call a function, the data is copied, cloned, and because of that, it is thread safe. Because you're always having your own local copy of the data, you don't share it with other threads.
Right. Okay. So,
but that is slow.
Yeah.
Sometimes.
Sure. It's always a trade-off. Yeah, exactly. There's always a trade-off in how that goes. So I was just thinking though about to your comment, like for example, of having a list of things, is that the individual things in the list may be immutable, but the list itself, or all of the data that exists, right? Individual pieces of data may be immutable, but the entire collection of data may not be immutable, right? And so we may have, it's still possible that you could have a situation where I might have some data that is newer than other data, so I don't have consistency yet. Is that accurate?
Yes, that's possible.
So again, it's not something I can just check it off and say, it's all immutable. No, so I've noticed in like for example, when using synchronize, as we discussed earlier, to synchronize between threads, usually the first parameter is nil. Is that always nil, or should that be? Or I've always been confused about that.
That is usually nil, especially in synchronize. That is you pass the calling background thread as parameter. If you need to know which thread called the synchronize in the context of the main thread. When the code runs in the main thread, you can use that parameter to whatever you need, if you need to know which thread called it. But it is more useful when you're queuing code, when you're not synchronizing, because if you pass the thread as a parameter, queue will automatically, when that thread is destroyed, it will automatically clear all queued events, all queued code. So you cannot have a situation when the queued events code will run after the thread is destroyed. But that only works, it doesn't work with thread pool, that is, you're using threads. It works only if you create your own thread.
So when I'm using queue, if I understand correctly, if I'm in a background thread and I'm calling into the UI thread, then from the background thread, I call queue to the UI thread, and I pass the background thread as the parameter, so that the UI thread knows which background thread added to the queue. Is that correct?
Yes. But when in queue, when you're queuing, this is handled in the thread destructor. Actually, it is not done in main. The main thread is not doing anything with it, unless you need to do in main thread. Unless you need to know which thread called that code. If you really need to know, but this is not something that usually happens. But if you're queuing, then the thread destructor will clean all the code that is associated with it, and it will clean all queued methods, because they will not run. They can run after the thread is destroyed.
Right.
So if you're using some local variables or something that is not that is released in a thread destructor or something like that, you have to prevent that code runs after the thread is gone.
So if the background thread is passing or calling queue, then is it the destructor of the background thread that clears the message out of the queue, or
yes,
is it the
destructor of the background thread?
Okay, so when the background thread gets destroyed, it notifies and removes all those things from the queue. Okay.
Yes. Basically, there is a queue list that is a global list of queued code for the main thread, where main thread, when it's done processing some messages and has time to do other work, it will go through that list and execute all the queued code. And when it does that, that code has associated thread ID with them. And when the destructor of the thread runs, it will clear all code with that ID, with its ID, so that code will not be in the queue anymore.
Okay, so I don't want to put something in the queue and then destroy my thread immediately, because that may not actually be handled. It sounds
depends if that depends whether that code needs to run actually, or it is just some label update or something that is not important. But if it's important to run, then you need to use some other method to send a message or something like that.
Okay. All right. So now, before we get on to some of the other questions, this is your second Delphi book, is that correct? Or do you have
Yes.
more? Okay, so your first one was on memory management, which is a great book on the understanding the way memory management work. And this is kind of tied into that because you do talk about like automatic reference counting and stuff like that and how it
Well,
figures
you
into.
need to know how to handle memory, because in threading it is more important to properly handle memory. You need to know how to work with that.
Okay.
It can create more trouble in multi-threading than in single thread if you don't know how to handle memory.
Sure, because you have to understand the life cycle of those.
Yes. It can crash more often, for instance, than in single thread. You can get away with some memory leaks or stuff like that, but in multi-threading scenarios, you can actually crash the thing if you don't know.
And then the book also gets into like this book also gets into like anonymous methods and inline variables and how those work within this as well. Is that right?
This book covers anonymous methods in depth, but not inline variables. It's not updated yet, but inline variables are still in some state of flux. They are still being polished, and not all code works as intended or expected. So you cannot guarantee that something that they write today will work like that tomorrow. There's still some parts of the feature, especially around reducing scope, that might be actual some bugs or not polished enough. So you cannot count on that it will behave like that when it finally settles down and it's really fully polished.
Yeah, that makes sense because that's the big thing with inline
variables. It takes some time to do that.
Is you're changing the scope of the variable, and that can
Yes.
behave in ways you don't, unexpected ways. So that makes sense.
Yes, but besides that, there's nothing so special about inline variables that will be different from general managing memory. Scope is the most important, and this part is still in the works.
Right. So, for somebody that is wanting to improve the responsiveness of their application, besides rushing out and buying the ebook so they can get the discount on the print book of your book, what is the thing they should really take away as the thing that would have the biggest impact on improving the responsiveness of their application?
Well, hard to say.
Hard to say. Okay, so I guess buy the book and start there.
There's too many things to think about it. Well, first thing is moving code to the background threads. But when you move in a simple scenario, it is simple. But when you start sharing data and you need to communicate with the background thread, and when you need to clean up the user interface properly on shutdown, or if, for instance, you're running something in background thread and form closes, and you have destroyed the user interface, you need to handle that situation so that background thread doesn't send progress messages to the destroyed user interface. So there are a lot of things that come to play when you are doing non-trivial scenarios. You need to handle a lot of things. You need to take care of plenty of things. It is hard to give, this is what you need to do and everything will be perfect.
You know, we always want those nice, clean, well-cut answers, but I think that's a good this fact that you can say that you don't give that answer and say it depends is a good that represents a good understanding of the situation, because it is never that simple. One question I do have, actually, one more question before we get on to the other questions, is let's say I have my user interface and I have multiple forms and I have some data modules that are going to have like connections to databases, stuff like that. And I want all of that to run in a background thread. Can I have an instance of my data module that's not running in the main thread, that's running in a background thread, so I can work with the components, non-visual components that way?
Well, if that depends, but basically you can have it if it's not being destroyed with in the context of the main thread. So if you auto create it when application starts, then it will have to go through some shutdown process. So that will work. But if you are creating it and destroying it in the applications manually through code, you need to, for instance, you need to create it without an owner, because if you have an owner, that owner can kill it at any time when you're still working on something. So that also depends. You need to have specific scenario to know what will actually happen. One line of code different and everything can fall apart.
Also, there is the new plugin. Have you used that new plugin, the Parnassus Parallel Debugger plugin?
No, I didn't have the time to check it. I'm interested, but I didn't have time.
Oh, I totally know what that's like. All right, fantastic. All right.
Debugging multiple threads is it's hard, and you need all the help you can get. So something like that is a very good addition.
Yeah, those I've talked to have used it really do enjoy it. So it's available and get it for anybody that's looking for tools for debugging. But all right, so we'll go into the rest of the questions now.
Yeah, thank you to everybody for joining us. We've got quite a few questions here to skim down. So a few at the start here asking for recommendations about approaches for handling exceptions and errors using the task libraries.
Well, that is covered in the book, but it really depends whether you need to just tee up exception and pretend like nothing has happened, or you need to show the exception and propagate. You need to know which exception exactly happened. Also, you can, if you need to tweet exception or just set up some error code or something like that, then you will handle exception inside of code that directly. You will not leave it up to, you will not propagate it up to the task, and T-task has exception handling. It catches all exceptions traced in the code you're wrapping. But you can handle exceptions after the task runs. You can see whether the task has raised some exceptions, and you can go through all the exceptions that were raised and handle particular exceptions after the task runs unsuccessfully, or you can directly handle exceptions inside the code you are running, but that depends on what you are doing and what do you need to do with the exceptions.
Yeah, so yeah, you still use t-except and try finally except, and
yes, you can use that inside the code.
Exception handling. So, yeah, it's just then how you raise it up. You need to just obviously be careful in terms of the way you raise it back up to the UI or to the user.
Yes.
Or if you need to. There's a question here from Sean saying he's already bought a copy of the book from Amazon. Is there a way to get the ebook? So yeah, just go ahead. I think Dalia's put her link for the website into the chat. So just go ahead and message her directly from there, and she'll be able to sort things through with you.
There was one question asked suggesting OmniThread library. The good thing is you can use any library. Basic rules are valid for any library you use. So book covers what Delphi provides out of the box. That is parallel programming library, T-thread, and create anonymous thread, and customizing T-thread classes. But you can use basic rules you learned from the book you can apply it on any other library, on any other code you are using. So this is universal knowledge. Examples are using Delphi code that comes with the RTL, but you can use any other library too.
Yeah, there's another question here that was asking about the futures, and I think there was a conversation on it during the webinar as well, about how to get if a future is actually returned back. There's actually something within the RTTI, the enumeration type get name you can call on the t-task status, and the status will tell you what it is, if it's running or if it's finished, also if it's waiting to run. So especially with one of the nice things with the parallel programming library and having the tasks and the futures is that if you've got 5 or 6 things that you need to run off and you set a wait for all to return, then depending on how many threads are available, the manager is actually going to handle kind of spawning those threads out. So you can actually see exactly which ones have run, which ones are waiting to run, and where things are at, which is pretty cool. So you know, that is a really nice thing that's around the tasks.
Yes, that's nice.
So have a quick look down here. There's a couple of questions around kind of database connectivity and multi-threading. So any kind of tips and tricks around?
Well, I'm not really a database developer. I know some ways around it, but this is not my primary. But the rules are the same. It is code just like anything else. Whatever you do with the database code, whatever you need to, just like with any other code, the thread safety considerations are the same. So if you share a database query or you are changing it, you cannot use it in multi-threaded scenarios. So whatever you need to do, you need to apply same rules for anything you're using. So you can safely use databases in threads, but you have to pay attention about global state and shared data, which you are changing. If you are reading something, just reading, you can share it freely. But if you are writing something and changing something, then you cannot do that from the 2 threads at the same time. So that is basic consideration for all code, regardless whether you are doing database or something else.
Yeah, so I think the main rule of thumb is just to make sure that you're not trying to push 2 different queries down the same connection at the same time to the database. You know, if you have got multiple queries, then you need to make sure that they're running in separate transactions. You know, the ideal thing is to use a connection pool, because if you have a connection pool, then you can have, you know, just a simple data module with your connection to the database and the transaction and a query on it. You can kind of pull those up, and then all the components are built ready to use. You just literally grab one of them from the pool, use it and put it back, and that then helps keep the you know, the multiple connections then help keep the thread safeness, you know, in the application. One other trick that I'll probably share with you guys is the T-client dataset has been really, really useful in the past. I did a web server application where we had a number of tables that were pretty much static queries, but were quite complex queries to run, and we needed to bring that kind of stuff available to all the threads to use. So actually using some T-client datasets, there's the ability to clone the cursor of a T-client dataset. So within the thread, you can create an instance of a T-client dataset, clone the cursor of the parent client dataset, which is part of the global memory, and then you can then work with it, filter it, have your own cursor to that data. And you can also then modify any fields on there, and the T-client dataset then manages pushing that back around to all the other threads. You know, as you access that query, it will navigate through and update the rest of them, which is pretty cool. And then obviously, if you need to post anything back down, then just using a single access points to control, you know, only one thread accessing the post mechanism to the data at the time is just pretty simple to do. So certainly there's components and access to moving data around quite nice within some of the components that are there. So
yes, you need to know the frameworks you're working with, and you need to know what the framework allows. That is not just with database, but the other things. You need to know what can be done and how can be used, and what is thread safe, what is not. Usually visual frameworks are not thread safe, but databases should be, and should have some ways to manage easily those connections and to allow thread safety. But it all depends on what you are doing. You can easily end in a mess if you don't follow the basic rules.
Great.
Well, there
okay,
was
go on then.
Another question about VCL and visual frameworks and thread safety. And generally, visual frameworks are not thread safe. There are some parts of where you can use some things that are thread safe, for instance, like loading bitmaps and preparing them for rendering. But that is always documented, and in general, it can only be used for that little small part that is documented to be thread safe. Otherwise, visual frameworks should not be touched from background threads ever. And there are some problems with T components. They are generally, because they have owner who can be a visual component. When you drop, for instance, some in the HTTP control on the form, you are binding that control with your visual, that non-visual control with that is thread safe. Otherwise, it would be thread safe to use. But you're binding it with the visual framework, which is not thread safe. And if that framework, if the form goes is closed and released before the thread is finished using that control that should be thread safe, it will not be. So there is something that has to be considered, but when people are using component-based non-visual controls that can be used in thread-safe manner, but they have to be careful when they are using them with in combination with forms and frames when they are just dropped on the form and used as part of the UI. That is something to consider.
Yeah, T-data module can be a very handy place for putting things to help be able to check when you've got things being used, and when you want to query to make sure that they're done with and dealt with before you kind of move on. There's a question here about your book. Is the T event object tackled? Precisely the cases in it must be preferred in case of T message. I'm sorry, trying to read a paraphrased message.
Yes, there is a T event, but in general, T event is a low-level part of the framework. So for end users, you will not usually need to use events. They can be handy for communicating between threads, but messaging systems are usually much simpler to use and set up. But there are examples with using T events, and it is not that is hard to use T event, but usually for most of the things it is simpler to use messaging of some kind than especially use T event. But there are examples of how it can be used.
Okay. There's quite a few multiple questions around the same kind of thing, which I think we kind of covered. So I'm just kind of having a look back down here.
Yeah, there was about synchronization and deadlocking. Yes, synchronization is very prone to deadlocking. So queuing is usually more prudent to use, but there are situations when you can use synchronize can be used freely. Depends what is called in the synchronized code. If you're using if you're synchronizing is similar to locking. If you are accessing some list that is shared between thread and between UI, then it is easy to deadlock to create deadlocks with that. For another thing is you can easily deadlock the UI if you are calling synchronize in the background thread and then you wait in the form destructor or something like that. You wait for that thread to finish or task. So you cannot combine synchronize with waiting on thread or on task. It will deadlock. Maybe not always, but certainly that kind of code is always that kind of coding pattern is always can always deadlock, because if you call synchronize at the time when UI is started destroying itself, waiting for the thread that is called synchronize will wait on the UI, and UI will not be able to do anything because it will wait on the thread. So yes, synchronize can be deadly.
Yeah, so there's a question here about some of the platform independent parts and also kind of what frameworks to use for getting out to all the different platforms. Obviously, you know, the key thing really, there's obviously we have the VCL for Windows, which is by far the best Windows development framework on the market, and some great exciting stuff coming in to some updates soon as well, which worth kind of keeping an eye on the blogs and what's happening around the Delphi birthday coming up on the 14th. And just keeping an eye out there. So I won't say more than that at the moment. But obviously the FireMonkey framework has been around now for, I think it's around about 9 years. Can you believe it's 9 years already? It's really maturing quite well. Yeah, since XE2. So you know, it still is very unique in the market in terms of what it's doing to provide developers a fully cross-platform framework that is able to compile down to native code. You know, there is no other framework for business applications doing that kind of side of things. And we're seeing, especially at the moment, kind of a rise with a number of kind of web hybrid type applications that are trying to spawn out and do Windows desktop application, which are incredibly hungry and on both, you know, memory and disk usage. And don't allow you to do the fine tuning that you can do with the, you know, with the frameworks that we have that are fully cross-platform, from, you know, database access to multi-threading to the works. So in terms of fine tuning and pushing out, which is the right, you know, just getting back to the question, you know, where should we be looking for the next 5 years? Well, it's right here with Rad Studio, because of the compilers that are there to get down to true native, and the ability that you get to be able to fine tune and speed up remarkably the applications with the kind of tips and tricks that we have, you know, through Dali's book. So.
Well, there is also thing VCL and FireMonkey are visual frameworks. So they are independent on the other parts of the. So it is all just like Legos. You can plug in the parts you need, you want to work with, and they are all independent, and they are not basically tied with asynchronous programming on or multi-threading. It is not something that is tied to a framework. You can use RTL provided parallel programming library. You can use some other library for that. You can use FireMonkey, you can use VCL, you can use any other framework, visual or some other that comes by. So it is all plug and play. You can mix anything independently if you want. So
yeah,
we already have what we have, and that will not change. That will not go away, and the new things will keep coming. So we have lot to work with.
No, absolutely. And I think it speaks volumes in terms of the design of the component architecture and the RTL within Rad Studio, that it enables us to so quickly get between different platforms. Having the strong interface design and setup that then hides the complexity of the layers right underneath, allowing us to actually move code cross-platform even when different messaging queues and all the other kind of things are built onto the platforms by having the FireMonkey one that we can use and the system messaging, which is fully cross-platform. It makes that task just so much easier and simpler, which is why so many frameworks now are looking at the component model as a way to go forward. And yeah, it's brilliant. Okay, so we're kind of past the top of the hour. There's a number of questions or comments, should I say, at the bottom saying, thank you very much for the session. There's been some good feedback on there. Yeah, just welcome to the community. Dalija's been around the community for a while, so but still, some thank yous for your contributions for the session. Question: how does your son see the future of Delphi? How are the new generation using it?
Well, I don't know. New generations are using everything, basically. When I started, people would usually use one language or maybe two, and they would stick with something for a long time, and we didn't have a reason to move around. But nowadays, everything is so connected, everything is so dispersed, and they really use anything that they can get their hands on. So those are the future generations. They will use whatever they need to use, and whatever they need to work with, they can quickly adapt. So we should learn from them. We should adapt much faster to new things.
Yeah, and I think we're actually, we certainly see, on the sales side, also working on the pre-sales side here, we see a growing number of companies who are looking in and mixing in and doing the right thing with that now. They've got established architectures and systems in place with kind of RESTful services, and the back end's already built, but they're needing to get out onto iOS and Android, but have specific requirements around security or speed and performance and native look and feel, which you can't get with some of the hybrid applications. And they're looking around at where to go. And more and more we're seeing a growing number of those moving into use FireMonkey, because it is the best way to kind of do that, and complementing their existing development team with with Delphi resources. So absolutely, I think that's a great reflection of what we're seeing. It just leaves it to me to say thank you to Jim for kicking this off today, and for the interview. Dalija, thank you ever so much for joining us for the session today and for the Q&A. I've had a sneak peek at her book, and it's really good. There's some very, very good stuff in there. So a wholehearted recommendation from me as well for it. Please, as I say, keep an eye out on the great stuff that's coming up around the Delphi's 26th birthday on the 14th. Blogs.embarcadero.com. There's a whole load of stuff going up through there at the moment, along with the events on the Embarcadero webpage, and where there'll be more of these kind of things coming up. So please kind of stay tuned. Please feel free to reach out to anybody if you have any follow-up questions that we haven't been able to answer or get to today. And thank you very much for joining us. Thank you, Dalija.
Thank you, everyone. Bye.
Goodbye. Happy coding, everyone.